At 19, alone on a ship crossing the Arabian Sea, he calculated something so profound it would take 53 years for the world to believe him. In 1930, Subrahmanyan Chandrasekhar, known to friends and colleagues as Chandra, boarded a steamship in Madras, India, bound for England. He'd earned a government scholarship to study physics at Cambridge University, one of the world's most prestigious institutions. He carried little with him: some clothes, a few books, and a mind that couldn't stop asking questions about the universe. The journey took weeks. While other passengers socialized on deck, Chandra spent his time with physics papers, reading Heisenberg's quantum mechanics, Schrödinger's wave equations, and thinking about stars. Specifically, he was thinking about what happens to stars when they die. Scientists knew that when stars like our sun exhaust their fuel, they collapse into dense objects called white dwarfs, remnants so compressed that a teaspoon would weigh tons on Earth. But nobody had asked the critical question: is there a limit to how massive a white dwarf can be? Alone on that ship, Chandra began calculating. Using the newly developed quantum mechanics and Einstein's special relativity, he worked through the mathematics of stellar death. And he discovered something extraordinary. White dwarfs could only remain stable if they were less than about 1.44 times the mass of our sun. Above that threshold, now called the Chandrasekhar limit, no force in the universe could prevent total collapse. The star's core would keep crushing inward beyond the white dwarf stage, forming something far more extreme. He discovered one of the fundamental boundaries of cosmic physics, and he was 19 years old, working with pencil and paper on a ship in the middle of the ocean. When Chandra arrived at Cambridge in 1930, he was excited to share his findings. Surely the brilliant physicists at one of the world's great universities would recognize the significance of his discovery. Instead, he encountered a wall of resistance. His supervisor, Ralph Fowler, offered tepid support at best. And then there was Arthur Eddington, the most famous astronomer in the world, the man who'd confirmed Einstein's theory of relativity, a towering figure whose approval could make or break a career. Eddington thought Chandra's calculations were wrong. Worse, he publicly ridiculed them. In 1935, at a meeting of the Royal Astronomical Society, Eddington stood up and declared that Chandra's limit was absurd, that nature would find a way to prevent such collapse. It was a public humiliation, a young Indian physicist being dismissed by the establishment in front of his peers. Chandra was devastated. He considered abandoning astrophysics entirely, but he didn't. Instead, he published his work in academic journals and moved on to other research, trusting that eventually, observation would prove him right. The racism Chandra faced in England wasn't limited to scientific disagreements. As an Indian man in 1930s Britain, he experienced social isolation, condescension, and the constant weight of being seen as an outsider in spaces that considered themselves the center of intellectual civilization. When opportunity arose, he moved to the United States, joining the faculty at the University of Chicago in 1937, where he would spend the rest of his career. There, he continued groundbreaking work in astrophysics, mentored generations of students, and waited. The universe, it turned out, was on his side. As telescopes improved and observations accumulated, scientists began finding evidence of stellar objects that had collapsed beyond the white dwarf stage, neutron stars, and eventually, black holes. Chandra's limit wasn't just correct, it was essential to understanding how stars die and what they become. The Chandrasekhar limit explained why some stars end as stable white dwarfs while others undergo catastrophic collapse, producing supernovae, neutron stars, and black holes. It was a key that unlocked our understanding of some of the most extreme phenomena in the cosmos. In 1983, 53 years after that ship voyage, decades after Eddington's public humiliation, Subrahmanyan Chandrasekhar received the Nobel Prize in Physics. He was 73 years old. The young man dismissed by Cambridge's establishment had been vindicated by the universe itself. In his Nobel lecture, Chandra was characteristically modest, focusing on the science rather than the personal journey. But those who knew him understood. This wasn't just a prize for scientific achievement. It was recognition that had come half a century too late, delayed by prejudice and institutional resistance to a young Indian physicist's ideas. Chandra died in 1995 at age 84, having spent 6 decades advancing our understanding of stars, black holes, and the fundamental structure of the cosmos. NASA's Chandra X-ray Observatory, launched in 1999, was named in his honor, a space telescope that studies the very phenomena his early work predicted. The story of Chandrasekhar is a reminder that genius doesn't require pedigree or privilege. It can emerge anywhere, on a ship crossing the Arabian Sea, in the calculations of a teenager with nothing but paper and pencil, in the mind of someone the establishment initially refused to take seriously. His discovery revealed something profound about the cosmos, that even the brightest stars, when they've burned through their fuel, must either find equilibrium or collapse into darkness. There's a limit, a boundary beyond which stability is impossible, and the universe has no choice but to create something more extreme. Perhaps there's a metaphor there, about institutions that resist new ideas, about establishments that dismiss outsiders, about systems that eventually collapse under the weight of their own rigidity. Chandra spent 19 days on that ship to England. In those days, alone with his thoughts and calculations, he glimpsed a truth about the universe that would take humanity decades to accept. He proved that sometimes the most important discoveries happen not in prestigious laboratories or famous universities, but in the quiet moments of solitary thought, when a brilliant mind, given time and space, can see further than anyone imagined possible. The young man on the ship knew something the world's most famous astronomer didn't, that in the face of overwhelming evidence, even the brightest authorities would eventually have to admit they were wrong, and that stars, no matter how brilliant, are not immune to the fundamental laws of physics. Neither, it turns out, are the institutions that initially dismissed him.